Hello everyone. So now we are solving the problem called minimize the maximum waiting time at synchronized traffic lights. So before we start, a quick reminder: believe in God, have faith in God. You might be following any other religion, anything you are following, but believe in His supremacy. I think if you don't believe in it, then it's impossible to achieve any goal, any dream, or anything which you have, right? So believe in God, believe in yourself, and keep up the hard work, right? So let's see the problem statement now. So you're given an integer period and an integer array lights, where lights of I is the duration in seconds of the green phase of the light, ith light in traffic. At time 0, every traffic light starts at the beginning of its green phase. The cycles are synchronized. Every traffic light starts a new cycle at same time, and every cycle lasts exactly period seconds. Therefore, the red phase of the ith light lasts for period minus light of I seconds. Right? You are also given an integer array arrival time, where arrival time is the arrival time of j is the arrival time in second of the jth car. Each car must be assigned exactly one traffic light. Multiple car may be assigned to a to a same traffic light. Any number of cars may choose to may cross the same traffic light simultaneously while they go green. Cars don't block or delay one another. For a car J assigned, let R be the arrival time modulo period. If R is less than light of I, its waiting time is 0. Otherwise, the waiting time is period minus R. Right? Now the problem, the penalty of assignment is a maximum waiting time among all cars. You need to return that element to be as small as possible. Now the problem itself is so huge that you might have forgot what we have read in the first line, right? So let me make it simple. Let's take the test case and try to understand it, right? Give me a moment. Yes, I hope I can copy it. Yes. So let me paste it here, right? And also this line, this thing is very important, right? Great. So I will give you a brief example of what the problem states so that we can understand, and then a single line will explain how we will solve the problem, right? So let me yes. Great. So let's read it. Let's see what the problem states. Let's understand via this example, right? Okay. So the light are 2 comma 3. The arrival time is 2 5 8 11, right? Right. So what are we going to do? We will take up this element. Let's take this blue color. Great. So what we are saying is, yes. So we will take this arrival time, right? And we will find the remainder, right? Let's call this as REM. REM equal to arrival time 2 modulo 8, right? Period is 8 in this case. So this gives us a value of 2. 2 modulo 8 is 2. If the light which you are choosing, you can choose either 2 or 3. The condition given was you can choose a light of j, whatever this, you can call this as j, this as j, whatever you can have. So you can choose a light of j, and that can be assigned to a single, to multiple cars, right? So like if you are having this 3, you can assign it as many times as you wish. You can assign it as n times, means the number of cars which you have, you can assign all of them to this car only, right? So this is the whole logic behind this. Now you might think, hey, why? But first let's try to understand it. So remainder in this case is 2, right? If R is less than light of j, so light of I, let's pick this in this case. So case 1 is we are picking lights of I. So I is equal to 2. So 2 is less than 3. So its waiting time is 0, right? So in this case, we will get a waiting time of 0, right? Okay, let's go on the next one. 5 modulo 8. 5 modulo 8 is 5, right? And if you choose, you can choose any of them. Even if you choose the largest one, which is 3, it is still greater than 5. 5 is still greater than 3, right? So in this case, the value that will be added, or the time or the waiting time becomes, let's write it as wt. Waiting time is period minus r. What was period? Period was 8. So 8 minus remainder which we got was 5. So 8 minus 5 gives us 3. So these are the values which we are having interested in, right? Okay, the third one was 8. Really sorry for that. 8 modulo 8 gives you a 0. So you can pick anyone. Let's say you picked this 2. You can pick this 3 as well if you think of it, right? So let's pick this 3 only, right? So 0 is less than 3. So the waiting period added will be 0, right? And the last one is 11. So 11 modulo 8 will give you a 3, right? And there is no element which is greater than 3, right? So at max you can choose 3 I equal to 2 as well, but still that condition not does not satisfy. So 3 is greater than equal to 3, right? So in this case we will have to add the waiting time. We have to find the waiting time. Waiting time is equal to whatever the period was 8. 8 minus 5, 8 minus 3, which is equal to 5. So out of these, what is the maximum value which you got? The maximum you got was 5, right? And you need to minimize this, right? This is the maximum out of all of them. You try to find, keep it as low as possible, still you reached 5, right? So 5 will be the answer in this case, right? So we need to keep this value as low as possible, right? Now how could you do this as low as possible, right? A very simple step will be the lights which we are given, right? Think of this. If you could, if you sort the lights, right, if you sort the lights, this will have the largest number which is possible, right? Now think of this. When we are doing this, we are trying to find this 2 modulo 8, right? 2 modulo 8 or any number x modulo period, right? Think of this. If this largest value is smaller than this value, then will this value have any importance? No, right? These values won't have any importance, right? Because if largest, let's say it was 100 and this value is let's say 200, right? And these values are 1 2 3 4, will these value be able to compete with it and get a value which is greater than 200? No, right? If 100 itself can't compete, then there's no point of having fight with these values, right? Yes or no? Am I making sense to you? So what you can say is, hey, how about I sort the values and I'm only interested in the last value, right? You can do it without sorting as well. You can simply store the maxi, right? In that case, the time complexity will be big of n, right? If you don't sort, but while contest I sorted, I didn't thought about going to maxi and all. So I, because time complexity is big of n log n, that is not that bad, right? Alright, so what we will do, we will simply sort the element. We will take the last element and we will do a check. Now, what is the check? The check is we will find the remainder. Remainder is nothing but the formula which was given to us, the formula which was arrival time modulo period, right? So, whatever the arrival time is, modulo period, right? And we will simply check, hey, if the remainder, if it is greater than the last element which we are, let's say whatever the name is lights, so lights of n, right? Lights of n minus 1, if it is greater, then you need to simply calculate the value. Int value will be equal to whatever the period is minus remainder, right? And maxi will be nothing but max of maxi comma val, right? You need to update the maximum value whatever it is there, right? So this is the whole solution there, that is it, right? Because we are interested in making sense that hey, if light of n minus 1 can't values is smaller than remainder, then you can do nothing, right? You need to go to value and update the maximum. That's it. So that was the whole solution. I hope the greedy solution, why this greedy solution worked, I hope it made sense to you, right? So that is it. A 10 line code, right? Sort it, right? We had an answer, right? We are traversing from 0 to n. We are finding the remainder arrival time modulo period. If remainder is greater than light of m minus 1, then we are simply interested in calculating the value which is period minus remainder, and answer is equal to maximum of all of those values, right? And we need to return the answer out of them, right? So if we talk about the time complexity, it is big O of n log n, right? And if you want to exclude this log n, you simply can traverse on the array and calculate the maxi, and you will be interested with maxi n only, right? So by this method you can exclude the log n as well, and now the time complexity will be big of n only, right? So I hope the solution was clear to you. If yes, you can do give a like and comment as well, if it was clear to you. And also, if you have any doubts, you can ask in the comments as well.